Ruth, welcome to Talk Satellite. Welcome to Talk Satellite.
Thank you, Kevin. It is such a pleasure to be speaking with you again.
Thank you for coming along today and sharing your experience with Talk Satellite followers. As predicted, those crowded skies are starting to creak somewhat.
I'm happy to look at the traditional factors. I mean, I think the big development in the last 5 years is the business case for the LEO satellites. And it's not like the engineers of the 1960s didn't understand that a low Earth orbit would be better for two-way communications, but it was not affordable. It was not in any way practical. They were really only looking at the broadcast of television or voice calls. So they went with the geostationary orbit, a brilliant, simple system. Still, the best orbit if you want to do one way point to multipoint or broadcast of any kind of signal, whether it's video or the one way updating of the software in every Kia car in all of the Americas, right? One satellite will do that brilliantly. But the applications that people want today are two-way. They're looking for two-way Zoom and FaceTime just to check their bank statement, texting, which can handle some delay, but the live video really can't. And for that, you need a lower orbit. Now that it is affordable to build and affordable to launch hundreds of satellites, it's happening. And it's happening at an exponential pace. I think we can both agree. Applications for traditional geos are diminishing. They will be there. And of course, you're going to want a geostationary for redundancy, resiliency, insurance. A little harder to shoot those out of the sky than your lower orbit satellites. I think that their day of being a primary type of satellite has gone. So, but the sharing of the frequencies is the same, whether you're in geostationary or LEO, and the more satellites that want to use KU, KA, it doesn't really matter which orbit they're in, they're all sharing. And that's going to force engineers to explore the higher bands, dynamic spectrum sharing, which I really have great hopes for. The regulators are going to have to consider rules that were set in place decades ago to protect the geostationary arc from spectrum interference of, at the time, what was more like little gnats, little flies in the sky, all those little irritating LEOs that were in the way of the big business money producing geostationary satellites. But that has flipped almost overnight. And so the protections for that arc are going to go away within the next years. That's my prediction.
There's always been types of interference in this industry. Now we're hearing of interference between the large LEO constellations and others. With further systems coming along online, we can imagine that things may well deteriorate further. What are you hearing in terms of how regulators are addressing these issues?
Well, the ITU's system of coordinating spectrum use is one of the greatest examples of cooperation in the world, really. I can't just be a bully or I just be the first one to outer space and start using the spectrum because other users will affect my customers as well. And so the cooperation has been very effective. I think that large LEO constellations will become the primary users of the Ka band, but I think that there is probably even insufficient spectrum for them to share, and they're already looking at the Q and the E band and moving their gateways perhaps to the higher bands, leaving the customers at Ka. I'm not quite sure. The engineers are definitely exploring all of these possibilities. And as there will be fewer geos, it will become easier to coordinate with them. So I think that there is a constant struggle, but I do believe that the engineers who specialize in this can handle this as well.
We hear companies such as Starlink would like to increase power, possibly for NTN, D2D. What headache
Yeah.
does this bring to the table for regulators, and are you expecting others to follow suit?
Yeah, I think there are two headaches. And the first is what I alluded to in my introduction, and that is the EPFD limits that were imposed in the 90s when a company called Teledesic first proposed a low Earth orbit constellation. The EPFD limits, equivalent power density, power flux density, it's a measurement of your power, the strength, right? And so they agreed at the work to keep the low Earth orbit EPFB below a limit that would interfere into the geostationary links. The oddity there was it was the entire geostationary arc, regardless of whether there was an active satellite in location or experiencing interference. So at a minimum, I expect that to change to not protecting the entire arc, but only specific satellites, and they'll work out coordination. But I also expect, if not at the next WRC, the one in 2031, that might go away completely, and that the geostationary satellites by then, probably a tenth the number that are up there now, are going to be the ones that will have to work around getting their link through the shell that is the LEO constellations. There are so many more uses for LEO that it is going to become the primary source of two-way communication in the world. So I think there's going to be that EPFD first relaxation and then possibly going away completely. The other issue you alluded to is D2D, or going directly from a satellite to a normal handheld device. So not a terminal that was designed for satellites, not a satellite phone, but your mobile, your cell phone. Right now, they are designed to communicate on frequencies for terrestrial cellular mobile phones. But both cell phone manufacturers and the mobile network operators and the satellite operators are all exploring two business models. So the business models are either to put satellite frequencies in that cell phone, the hardware, right? Just like it has a whole range of cellular frequencies. Well, for example, is the first, I think the first company to have put L-band spectrum capability in its hardware, so that in an emergency, as it started out, an Apple phone user could use the global star satellite constellation to send texts to get help. The other model, which is what I think Starlink is exploring, is to put the cell phone frequencies on the satellite so that you wouldn't matter what hardware, whether you had a Samsung or an Apple phone, would matter who your mobile service provider was. So if you had Orange or AT&T or Telstra, they would have to have a contract with the satellite company, and then you would be able, again, in an emergency, to send a text to get help. And right now, by the way, it is mostly, I think it is really only texting, but all of the companies are working at voice. And of course, two-way video, 4G quality will be the holy grail that we hope to get enough power to close that link. The reason one is easier for regulators than the other is because throughout the world, the terrestrial mobile network licenses have been auctioned, right? The mobile phone companies, by and large, have bid millions, if not billions of dollars for the right to an exclusive license, a little tiny sliver of that band in each nation where they operate. If they are about to become an irrelevant middleman because my hardware can now talk directly to a satellite, they're not going to be happy. And they're not going to be happy in 92 countries. Regulators that took that money and gave them that exclusive license are really in a tough position, because although they might like a business model that is more freeing for a consumer and allows the consumer to choose the hardware, choose a satellite that it wants to use, it's not the consumers that paid for those licenses, right? So until that can be resolved, I think regulators are going to favor the model, at least in the short to midterm, that causes the least harm to its incumbents. And that may change again, 5 to 10 years. I expect that the cell phone companies will invest in satellite as well as the hardware deals that they've made. And so it will become less important to them which business model is used. And the next World Radio Conference coming up in 27 is already looking at D2D, how that will affect the allocations for satellite and cell phone.
Of course, the government use it. They would like their sovereignty and their security in that GeoArc. Have they got to be more active now to secure their signal against that LEO interference or that LEO encroachment? And where we are with this issue, do you envisage time when LEO will have priority over GEO? and
Yeah.
how will governments be able to manage those situations?
The cow has left the barn. There's no question that technologically, Leo is a superior technology for the applications that we use today. And so there's nothing the geo operators can do to make their technology competitive with that. They just can't. So they can attempt to stand in the way of progress, but no one's going to appreciate that from an objective point of view. But again, many of these satellites are national satellites. They were put up by the government or with government investment. And so, again, we have a situation where a government has to recoup its investment. And there's also a great sense of national pride in having a national satellite. Every nation has justified them by a requirement for national security and for the privacy of their citizens' communications and for the government's ability to intercept illegal behavior, what have you. So they have great national security interests in the control of all their communications, but certainly these geostationary satellites. And again, I think what we're looking at here is a need to find a model by which every nation of the world can participate in one of the constellations. I don't think it's possible for every nation to put up its own constellation the way most nations were able to put up their own geostationary satellite. You can't have like a satellite in the Starlink constellation and say this one belongs to Uruguay and that one belongs to Mali. So, but I do think that those smaller countries that can't afford their own constellations will want to have a sense of national pride, a sense of investment, and sense of security that somehow this is their national system. And I think that will be an interesting approach by both the Chinese and Starlink and Kuiper, and just as likely the European Iris Squared. I think that all of these systems are going to be looking at how to be part of many, many nations as opposed to merely American Starlink in the sky.
That was a great point you made regarding the mobile operators and the very expensive auction that took place. Be interested to follow that. Would you be able to give us a little bit more detail on the direct-to-device and the 2 gigahertz L-band allocations for MSS? Your thoughts on how those systems will kind of develop?
Yeah. So as I mentioned, Apple is already basically the biggest customer on Global Star, and the L band is important because the main use of the L band has been in Inmarsat at the geostationary. And I think that I know that the US is already looking at this. I think the UK is looking at this. I think that the allocation for mobile satellite service, which has traditionally been L band 2 gigahertz, more or less, is going to be revisited. And I think it's probably going to be either open to both non-geo and geo, because they're not going to squeeze out Inmarsat. Who the heck wants a terminal anymore when you could have something smaller that was higher speed, better quality, and followed you everywhere in the world? I do think that there's going to be a significant shift, as I said, allowing the NGSO into the 2 gigahertz. Again, I think that the two business models, the UK, I like it, they call it, I think, D2D via MSS or D2D via IMT. That's again, whether you're putting the satellite MSS frequencies in your cell phone hardware or whether you're putting the cell phone IMT frequencies on your satellites. I think they're going to allow both and sort of let the marketplace figure this one out for a few years. It might be a bit like the old beta versus VHS videotape for those of us who are old enough to remember that. Losing app to be a better quality technology. Beta was a great technology, but VHS won in the marketplace. And it could be that that is true with the D2D. For example, perhaps the Apple business model of putting the L band frequencies in its hardware is a superior technology, but maybe if Kuiper and Starlink are doing the opposite, their marketing will be so overwhelming that that will be the winning business model in the world. We're right in the middle of this, Kevin. Hard to predict, but I think, within 3 to 5 years, we'll know which way is going to succeed.
Fascinating, Ruth, and thank you so much for coming along today and touching the surface of what's about to be bestowed on us.
And thank you. I love talking about this stuff. It really is so incredibly exciting and vibrant. And massive, massive changes in space-based technology.